Hello and back to another video. In this video we are going to discuss the solutions of the Pure Mathematics 3 October November 2019, and the code is 9709, component is 3.1. So in this video we will be discussing the question number 1, 2, 3 and 4. So without delay, let's start with the question number 1. Here's the question number 1. Given that ln 1 plus e raised to the power 2y is equal to x, and express y in terms of x, so we are going to use the basic definition of ln. That is, we know that if b raised to the power y is equal to x, it means log base b x is equal to y. So if the base is e, then this is represented by ln, the natural log. So we can compare it. It's like if e raised to the power y is equal to x, it means ln x will be y. So this is the basic definition. We are going to use it and we'll get e raised to the power whatever comes with the x will go that side. So e raised to the power x is equal to 1 plus e raised to the power 2y. So we need to express y in terms of x. So first of all, we will take e raised to the power 2y one side and we'll get it as e raised to the power x minus 1. And hence again we are going to use this definition. So we will get 2y is equal to ln e raised to the power x minus 1. So y become 1 upon 2 ln e raised to the power x minus 1. So that's the y in terms of x. I hope it is clear. Let's do the next question. Here's the question number 2. Solve the inequality modulus 2x minus 3 is greater than 4 times x modulus x plus 1. So whenever we have modulus both the side, the easiest way is to solve by taking the square both the side. Otherwise we can draw the diagram also and we can see from there as well, but the best way to take the square both the side. So squaring both the side, we will get rid of this modulus and inequality will be as it is. So we'll get 16 times x plus 1 whole square here, or if you'll open it, we'll get 4x square, 3 2s are 6, 2s are 12, so minus 12x plus 9 greater than 16 into x plus 1 whole square, and x plus 1 whole square is going to be x square plus 2x plus 1. So it would be 16x square plus 32x plus 16. So I'm going to transfer everything to the right hand side, and this inequality I'll write like this, and so that I'm going to transfer everything to from the left hand side to the right hand side, but I'll write to the left hand side. So 16x square minus 4x square is 12x square. 32 plus 12, because it is minus, 32 plus 12 would be 44x, and 16 minus 9 is 7. So it is going to be plus 7 and less than 0. So now we need to solve this quadratic equation. We'll find the root, and since the graph is upside down, that is a cup shape, so we'll get the minimum point here, that is different thing, but we are going to get the two roots. And since we require the less than 0, it means the below x-axis part, so the x values will be these values. So let's find the roots. For that we require to solve for 12x square plus 44x plus 7 is equal to 0, and if we'll solve, we know it is going to be, so 12 into 7 is 84, and we know 44 can be split as 42 plus 2, so it's going to be 12x square plus 42x plus 2x plus 7 is equal to 0. Now if we'll take 6 common, I'll take from here 6x, sorry, then you will get 2x plus 7, and in these two terms we can take only one common because nothing else is common, so it is going to be this. So from here we will get x values directly as minus 7 over 2 and minus 1 over 6. So minus 7 over 2 and minus 6 1 over 6. So this is going to be minus 7 over 2 and this is going to be minus 1 over 6, because 1 over minus 1 over 6 is more than minus 7 by 2. So for these inequalities, we are going to take the x in between these two values. That is, x will be greater than minus 7 over 2 and less than minus 1 over 6, and that's the solution. I hope it is clear. Let's do the next question. The third question, the parametric equation of a curve are given. So we have x in terms of t and y also in terms of t, and we require dy. We need to show that dy over dx is equal to cosec 2t. So we know we are going to use the chain rule, because it is like we can solve d over dx, dx of y or dy over dx is equal to dy over dt. Why dy over dt? Because it is a function, y is a function of t, so that's why it is dy over dt we can find. And then it is 1 upon dx over dt, so we can write dt over dx. So it means we'll find the dx over dt from here, and then we'll divide it, or we'll take the reciprocal of it and we'll multiply in dy over dt. So first of all, let's find dx over dt from here, and we know this is 2t, so it is going to be 2 and plus sine 2t differentiation with respect to t, so it is going to be cos 2t, and the differentiation of 2t, that is going to be 2. So I should have written it here, that's fine, and we'll take 2 common. It is going to be 1 plus cos 2t. Now I know that there is a double angle of cos, so we can simply remove this plus 1 by using that double angle formula for cos 2, that is 2 cos square theta minus 1. So this will be gone, so it is going to be 1 plus 2 cos square t minus 1. So these two got cancelled, so we only got 2 into 2, that is 4 cos square t. Now the term for dy over dt, differentiation of y with respect to t, and it is going to be, again we are going to use the chain rule. First of all, it is ln of this function, so dy over dt of this is going to be 1 upon the function, that is 1 minus cos 2t, into the differentiation of this bracket, that is 1 minus cos 2t, that is going to be 0 minus, and cos 2t differentiation will be minus sine 2t and into 2, so it is going to be minus minus plus and 2 times sine 2t. So and now if we'll simplify it, we are going to get 2 times sine 2t over 1 minus cos 2t. So again 1 minus cos 2t, we will use 1 minus 2 sine square t, double angle formula for cos 2t, cos, and now we'll use the double angle formula for sine also, and we'll get sine 2 is already there, so it is going to be 4 sine t into cos t upon, now we'll see these two will be cancelled and we are only left with sine square t. So 2 will be cancelled, 1 sine will be cancelled, and we are only left with cos t upon sine t. So it is going to be cos t over sine t. Now finally we'll get the dy over dx here by substituting the value here, and that is going to be dy over dt, that is cos t over sine t into dx over dt, reciprocal of this because it is dt over dx, so it is going to be 1 upon 4 1 upon sorry, here I left 2, so it is going to be 2 here, and 4 cos square t cos square t. Now we can see one cos will be gone and 2 will be cancelled. So we are only left with 1 upon 2 sine t cos t, and that is going to be sine 2t. So let me scroll it up. So we will get it as 1 upon sine 2t, and that is cosec 2t, because reciprocal of sine 2t is cosec 2t, and that is the last part we need to do. That's hence it is proved or shown. Let's do the next question. Question number 4. The number of insects in a population T weeks after the start of the observation is denoted by n. The population is decreasing at a rate proportional to n e raised to the power minus 0.02 t. So first thing we got to write from here, the population is decreasing at a rate of it, and population is n, so we can write dn over dt is proportional to, since it is decreasing, so I'll apply minus n e raised to the power minus 0.02 t. So if you want to remove this proportionality sign, we'll apply equal to and a constant here. So we'll get dn over dt is equal to k, and minus is of course there, n e raised to the power minus 0.02 t. So now we'll apply the first condition. The variable n and t are treated as continuous, and it is given that when t is equal to 0, n is equal to 1000, and dn over dt is given as minus 10. So we'll use only when t is equal to 0, dn over dt is equal to minus 10 here. So we will get minus 10 is equal to minus k, n is going to be 1000. Of course we are going to use this also. So 1000 e raised to the power 0. So e raised to the power 0 will give us 1. So from here we got k as 10 over 1000, minus sign is also got cancelled, and we got it as 1 over 100. So dn over dt is dn over dt by replacing this k value as 1 over 100, and 1 over 100 is 0.01 because it is 0.01 given here. So we got the answer from here, 0.01 e raised to the power minus 0.02 t into n. And that's it for this. Let's do the next part of the same question. So second part is solve the differential equation and find find the value of t when n is equal to 800. So first of all, we have a differential equation here. So from here we can write dn over n is equal to, I'll do the integration sign also, integration of this at minus 0.01 e raised to the power minus 0.02 t, and then dt. I transfer it another side. Now if we'll integrate it, we will get dn over n is ln n, and is equal to, if we'll do the integration of this, minus 0.01 is a constant, so it would be outside, and integration of e raised to the power minus 0.02 will be e raised to the power minus 0.02 t, and divide by differentiation of this, and that is going to be minus 0.02 only because t will be omitted, and plus a constant of integration. So now we can see, we can simplify it. These two will be cancelled. This is going to be 1 time, this is going to be 2 times. So ln n is equal to 1 upon 2 e raised to the power minus 0.02 t plus a constant here. Now it is given when t, the first one also only, when t was 0, n was 1000. This is the condition given in the first part only, before in the question only. So we will get ln 1000 is equal to 1 upon 2, and we'll put t is equal to 0, this is 1, so plus c, or we got c value as ln 1000 minus 1 by 2. So once we got c value, we'll put here, and we will get ln n is equal to 1 over 2 e raised to the power minus 0.02 t plus ln 1000 minus 1 over 2. And this is the equation. We can write in the terms of n also, but that is fine. Now we need to find the value of t when n is equal to 800. So we'll put n is equal to 800, and I can transfer this thing over the another side. We'll get ln 800 minus ln 1000 is equal to 1 upon 2 times e raised to the power minus 0.02 t minus 1, and this is ln 800 minus this, so minus means division, so we'll get ln 8 over 10, that is 4 over 5. So from here we can write e raised to the power 1 upon 2, of course, or let me transfer 1 upon 2 also to the other side, and when you will transfer to that side, it will be minus 0.02 t minus 1 is equal to 2 times ln 4 over 5, and ln 2 is multiplied, so it will go in the power, and we will get e raised to the power minus 0.02 t is equal to, I'm transferring this thing also to the other side, it would be 1 plus ln 16 over 25. So now we'll use the definition of this, e raised to the power all, and hence we'll get 0.02 t is equal to, see, we are going to is equal to ln of 1 plus ln 16 over 25. This is the basic definition of the ln. From here, like e raised to the power y is equal to x, it means y is equal to ln x. This is what I have applied here. Now, so t will be 1 minus 1 upon 0.02, that is going to be minus 1 upon 0.02 ln of 1 plus ln 16 over 25. We'll put the these values in the calculator, and we will get it as answer, and the answer is 29.555 and so on. So it can be written as 29.6 seconds. So I hope it is okay. Let's do the last part of this question. Third part, state what happens to the value of n as t becomes large. T become large means, let's say, it is tending towards the infinity. So let me bring the equation which is in n. So here is the equation from the second part, that ln is equal to half e raised to the power minus 0.02 t plus ln 1000 minus 1 by 2. Now here, if t tends to infinity, this will tends to 0, so this is gone, and ln 1000 is there, minus 1 by 2, so I can write 1 by 2 as ln e into 1 by 2, because we know that log base a and a is always going to be 1. So similarly, if it is ln e, this will be 1, because ln is the log base e, it is natural log. So we'll write it again, ln n is equal to, this is a multiplication, so it would go in the power, so it become e raised to the power 1 by 2, and there is a subtraction, so it would be ln 1000 over e raised to the power 1 by 2. Now we can take the n is equal to 1000 over root e. This is the value of n when t becomes large. So that's it. We'll be solving the other questions in the next video. Till then, thank you so much.